There's something weird going on around the planet Uranus. Some of its moons and rings don't orbit in the same plane as the planet's equator. It's like they're orbiting sideways. And scientists think there's one weird event responsible for it all. But what was that? A wayward Kuiper belt object captured by Uranus's gravity, or the debris left over from a long-ago crash? Let's get into it. Uranus is sideways. That's not an opinion, it's a scientific fact. The planet is almost perfectly on its side relative to the Sun. Its axis is tilted 98 degrees out of the orbital plane that it shares with the other planets. You might know this as the ecliptic plane. This strange tilt means that Uranus has extreme seasons, each lasting about 21 years, as well as dramatic temperature swings between summer and winter. But our solar system's only ice giant isn't the only thing with an extreme tilt. A few of its moons and rings also have highly inclined orbits. For example, Miranda, which is about 470 kilometers or 300 miles across, whips around Uranus just 980 kilometers or 610 miles above the surface. That's closer than any other moon in the solar system, except for the satellites of Jupiter's moon Europa. Miranda's orbit is also extremely inclined relative to Uranus's equator. It's tipped nearly 52 degrees out of the planet's orbital plane. So Miranda is orbiting Uranus in what seems like almost the same plane as the Sun. And Miranda isn't alone. Uranus's largest moon, Titania, which is more than 5 times larger than Miranda, has an orbit that's inclined 41 degrees out of the equatorial plane. And another moon named Oberon is inclined 19 degrees. Not to mention several of the rings that surround Uranus also have these funky orbits. They include the opaque ring system known as the E-ring and a faint opaque ring called the F-ring. Even weirder, the E-ring doesn't even wrap around the planet. It's opaque only on one side of Uranus. So why aren't all of these moons and rings orbiting in Uranus's equatorial plane like most other moons in the solar system? There are a lot of different theories, but scientists seem to think there's one weird event responsible for most of the offbeat orbits. So what could that be? Well, let's start with the leading hypothesis, the capture scenario. This idea suggests that all of these objects were once part of the Kuiper belt, a collection of icy bodies that surrounds the Sun between Neptune's orbit and Pluto's orbit. But eventually they got too close to Uranus and the planet's gravity altered their paths. Instead of flying past Uranus and continuing on their path around the Sun, these objects became trapped in orbit. But if that happened, why did they end up so far from the planet? Well, they probably started out much closer to Uranus, and the gravitational pull of one or more moons nudged them farther out. But this raises another question. If capturing these objects took millions or billions of years, shouldn't we see more moons and rings with intermediate inclinations between the equatorial plane and their current orbits? Well, maybe. But keep in mind that the moons and rings we see now are likely the final result of a long process of gradual orbital adjustments that may have taken hundreds of millions or even billions of years. The objects captured from the Kuiper belt likely underwent many collisions with each other and with Uranus's existing moons and rings. These interactions would have gradually shifted their orbits until they settled into their current configuration. So there could still be more moons and rings with intermediate inclinations that we just haven't spotted yet. It's also possible that some of the moons and rings we see today are actually captured Oort cloud objects, meaning they were never part of the Kuiper belt to begin with. You see, the Kuiper belt isn't the only reservoir of icy objects in the outer solar system. There's also the even more distant Oort cloud, a theoretical sphere of icy bodies surrounding the entire solar system. If any of the objects in the Oort cloud got too close to Uranus, they could be captured as well. In fact, some computer simulations suggest that objects from the Oort cloud could explain the high orbital inclinations of Miranda and the E-ring. There's also evidence that at least one of Uranus's moons, Ariel, has a highly inclined orbit because of an encounter with Neptune. Computer models have shown that a close encounter with a massive planet like Neptune could easily kick a moon into an inclined orbit. But if that's the case, Why does Ariel look so geologically active? Scientists think that the energy from the close encounter between Uranus and Neptune may have been enough to heat Ariel up and make it volcanically active. Now, while the capture scenario seems to explain a lot of the features of Uranus's moons and rings, it leaves one major question unanswered. Why are so many of them non-circular? Astronomers can describe the shape of an orbit using a value called the orbital eccentricity. An orbit with an eccentricity of 0 is perfectly circular. But as the value gets higher, the orbit becomes more elongated. For example, Earth's orbit around the Sun has an eccentricity of 0.0167. In comparison, Pluto's orbit is highly eccentric with a value of 0.249. Most of Uranus's moons and rings have orbital eccentricities greater than 0.1. Which means that they travel thousands of kilometers farther from Uranus every year than you would expect if their orbits were circular. The leading explanation for these elongated orbits is that something big has crashed into them. This could have happened early in the solar system's history, when Uranus formed from a rotating disk of gas and dust. If a large object slammed into the young planet, it could have knocked moons or rings out of circular orbits. What's interesting is that all of the moons and rings with highly eccentric orbits are also the ones with high orbital inclinations. That makes the collision hypothesis all the more appealing. It suggests that whatever caused Uranus to tilt on its side may have also kicked many of its moons and rings out of their orbital planes. And scientists think they know exactly what this cosmic crasher was: Uranus's mysterious second largest moon, known simply as the Witch Moon. According to simulations, the Witch Moon could have formed in a dense region of gas and dust near Uranus's equator. But as it drifted away from the planet, its orbit grew increasingly unstable. Eventually, the gravitational pull of the moons in Uranus's tight inner group, including the large moon we know as Titania, knocked the Witch Moon out of orbit and sent it crashing toward the planet. The impact heated the Witch Moon and Uranus's surface until both bodies were completely vaporized. All that was left behind was a thin layer of solid material that reformed into Miranda. Meanwhile, the debris from the explosion spread around the planet, forming the rings and kicking moons and rings out of the equatorial plane. To be clear, no one knows exactly how or why Uranus ended up with its moons and rings in such weird orbits. There are lots of other possibilities. We've covered two of the leading scenarios here, but it's possible that others are at play. Maybe some moons and rings really did come from the Kuiper belt, and others really did come from the Oort cloud. Maybe they were all captured during different periods of time. Or maybe some moons and rings were formed after the Witch Moon hit Uranus. In any case, the story of Uranus's moons and rings is complicated and far from over. As with all mysteries, though, the real fun is in the hunt for clues. And thanks to the amazing technology we have today, we can go back in time and study the clues for ourselves. Let us take a quick time machine ride back to 2015, when NASA launched the New Horizons spacecraft on its journey to Pluto. But before swinging by Pluto, New Horizons had a flyby with a less famous Uranus. The mission flew within 200 kilometers, or 124 miles of the planet. That gave the probe a gravity boost that would help it reach Pluto without using any fuel. During the approach, New Horizons snapped pictures of Uranus's rings and atmosphere. But in 2019, scientists made a surprising discovery. Hidden inside some of the images were hints of a previously unknown ringlet known as the Ring. It's a faint, narrow ring located just outside of Uranus's main rings. What's especially interesting about the ringlet is that it appears to be opaque only on the side of Uranus facing away from the Sun. Scientists think this is evidence that it formed from debris thrown off of Miranda, when the Moon crashed into the planet. Unfortunately, due to technical limitations, the ringlet is only visible in ultraviolet light, and since then, researchers have struggled to figure out exactly what it's made of. In 2021, though, a paper published in Nature Astronomy presented evidence that the ringlet is opaque, only because it's full of ice crystals. The rest of the ringlet is probably made of rock and dust. What's more, scientists have used data from the ringlet to learn more about Miranda's orbit. Since the moon's gravity pulls on the ringlet as it moves around the planet, researchers can use the movements of the ringlet to work out Miranda's mass. They found that Miranda is about 3 times more massive than the Earth, making it the 4th largest moon in the solar system. With data like this, scientists are getting closer and closer to solving the mystery of Uranus's weird moons and rings. Maybe we'll find that the truth is stranger than fiction. Or maybe the answer will point to an entirely new area of space exploration. Whatever happens next, you can bet we'll be along for the ride. Thanks for watching this Sea Show Space video.